Hi everyone, in today's lesson we're going to talk about how to solve equations by completing the square. Before we can actually get into solving by completing the square, I'd like to review a few things first. First, I'd like to review what is a perfect square. A perfect square is a number or an expression that is the result of two of the same things multiplied together. So for example, 25 is a perfect square because it's the result of 5 times 5. How about x squared? X squared is a perfect square because it's the result of x times x. Okay? How about 4x to the 6th? That's a perfect square as well because that one's the result of 2x to the 3rd and 2x to the 3rd. So these are all perfect squares that we've learned before. Now we can also have perfect square trinomials. So a perfect square trinomial is a trinomial that is the result of two of the same binomials multiplied together. So if I took these two binomials that are the same and double distribute them, you would get x squared plus 8x plus 16. So that makes this trinomial a perfect square. Now let's look at these two binomials. We're multiplying two of the same binomials together, and if you double distributed everything, you would get x squared minus 6x plus 9. Now this trinomial would also be a perfect square trinomial. So what do all perfect square trinomials have in common? You may not be able to see it just by looking at just two examples, so I'm just going to tell you what it is. A perfect square trinomial is any trinomial whose c value is half of the b value squared. Now I know that's a lot of jargon, and what does that really mean? And we could put it into words. It's really you're going to take half of the b value and square it. And we want to see if that gives you the c value. Now what do I mean by a, b, and c? We've gone over this a few times, but remember we have a trinomial that's ax squared plus bx plus c. So let's just prove to ourselves that these two trinomials fall under this same pattern, that their c value is half of b, or b divided by 2, squared. So let's look. My c value here is 16. Is that half of 8 squared? Well, let's do the math. 8 divided by 2, that's half of it, squared. Well, half of 8 is 4, and then 4 squared is 16. Okay, that one works. Let's look at the second example. Take half of the b value. The b value is negative 6. We're going to have it. And square it. So negative 3 squared, is that equal to 9? Yes. So in both of these cases, my c value was half of the b squared. Okay. Now let's look at 3 more examples and determine if they're actually perfect square trinomials or not. And if they are, let's factor them. So let's look at example number 1. To see if it is or not, we're going to look at the c value and see if it's half of b squared. So we're going to take negative 2 divided by 2, and I'm going to square it. So negative 2 divided by negative 2 is negative 1. Negative 1 squared is 1. Okay, so that works. Let's look at example 2. Half of b, so we're going to take 10 divided by 2 and square it. 10 divided by 2 is 5. 5 squared is 25. So that works nicely. Okay, now let's look at this last one. We're going to take half of the b, so negative 12 divided by 2, and square it. So negative 6 squared is 36. So that one works as well. Now let's factor these. So if you notice, we can just use the AM method for these because the a is equal to 1. So if I look at this quickly, this will just be x minus 1 times x minus 1. Number 2 will be x plus 5 times x plus 5. And number 3 will be x minus 6 times x minus 6. Now, do you notice anything in particular to how we could just write these? Can't we write them as x minus 1 squared? Can't I write this as x plus 5 squared? And this as x plus 6 squared? because anything times itself is that same thing squared. So this is just a quick way of realizing that you really don't have to do AM. What you really could compare is that when we take half of it, half of b, we get -1. So look at this, -1. When I took half of my b, which is 10, I got 5 and squared it. So that 5 went in here. Half of b is 6, that goes there. So the rule is it's going to be half of the b value will help us factor. So all of these guys in here are half of the b value. So let's see if we can put this all into perspective. Determine what the c value would have to be to make this a perfect square trinomial, and then rewrite it as a binomial squared. So first one, in order to find the c, we have to take half of b, so -4 divided by 2 squared. Now -4 divided by 2 is -2, and -2 squared is 4. So that's my c. Now why did I write all of these steps out? Because remember, when we took half of b, we got this step. This is the step of my factoring. So it's going to be x minus 2 squared. Okay, so for number 2, we're going to take half of b, which is 6 divided by 2, square it. So we'll get 3 squared, which is 9. So that's my c value. Now remember, half of the b value, which is the 3, tells us how to factor it. So it'll be x plus 3 squared. Now example number 3, take half of b and square it. So I get 5 squared, which equals 25. So that I'll put there. And this half part is what tells me how to factor. So those are my pieces. So if you could do this page, you definitely can factor by completing the square. So let's go to the next page. Okay, so the directions are saying to solve each expression by completing the square and then describe the roots. So the first thing that I want to do is set the equation equal to 0. So I've set it up into 3 different scenarios, or so far here there's 2. We're going to have where a is equal to 1, so a is the a value equal to 1, or where a is greater than 1, which is here. So let's just see what we're going to do first. So again, like I said, we're going to set the equation equal to 0. So this equation is perfect. Step 2, the x squared must have a coefficient of 1. It does, so we don't need to do anything. So now what we really have to do is create a perfect square trinomial. Because right now, this trinomial is not a perfect square. What would this c value have to be to make it a perfect square trinomial? Well, you're probably saying I need to take half of b and square it. So let's do that. The b value is -8. We're going to divide it by 2 and then square it. So -8 divided by 2 is -4. -4 squared is 16. So that tells me that if this trinomial were a perfect square, this c value would have to be 16. So by completing the square, I'm going to make my own perfect square trinomial. So I'm going to take that 16 and add it and then subtract it to the left side of the equation. That is my step 3. So let's do that. We have x squared minus 8x plus 16, and then subtract the 16 again, and then bring down the plus 24 equals 0. Now let's talk about why I added it and then subtracted it. If I add 16 and then subtract 16, I'm pretty much adding 0. So I'm just adding a different form of 0 so that I can complete the square. So I can take this trinomial and factor it using that trick. That trick is that it's half. So we're going to make this x minus 4 squared, and then I can simply add -16 and 24, and I get -8, or positive 8, sorry, equal to 0. And now I really want to solve this equation, kind of like the quadratic formula, for this x value. So first I need to get rid of this positive 8. So let's subtract that on both sides. I'll be left with x minus 4 squared equals -8. Now if I want to get this x in here by itself, I need to get rid of the squared. And in order to do that, I have to square root both sides. So the square and the square root will cancel each other out over there. And we'll be left with x minus 4 equals the plus or minus, don't forget plus or minus, the square root of negative 8. Okay, now we're almost done. To get x by itself, all I have to do is add the 4. Now it's more proper when we write this that we don't write this plus 4, but we put the single number first. So we're going to do 4 plus or minus radical negative 8. Now we actually can simplify this a little bit more, so let's do that. We actually can simplify the square root of negative 8. Remember, we could pull the negative out and make it I rad 8, and then break up 8 into the square root of 4 and the square root of 2, which becomes 2 rad 2 with the I in front, so 2I radical 2. So my final answer is x equals 4 plus or minus 2I radical 2. Now what type of roots do I have? You should be saying imaginary because there are i's. Okay, I know that was a lot, so I'm actually going to review everything that I just said. So for completing the square, our first thing we want to do is set the equation equal to 0. I did that here. Okay, now I said to myself, this trinomial is not a perfect square trinomial, so I'm going to try to make it one. So I did half of b and squared it. Negative 8 divided by 2 and squared it, and I got 16. So I added that 16 here, so now this trinomial is a perfect square. But I can't just add something to one side of the equation. It's got to be even. So I subtracted it too, so that it equals 0. So then I factored this trinomial into x minus 4 squared plus 8, because I added these two, and I got it equal to 0. Then I said to myself, well, I have to solve for this x, so I'm going to subtract the 8 first. Then to get rid of this square, I square rooted it. And then I always remember the plus or minus when I'm taking a square root. Then to get x by itself, I added the 4. And then I wrote it properly with the single number first. 4 plus or minus radical negative 8. And then I just simply simplified radical negative 8. And I got this as my final answer. Okay, let's try a different example. Let's try an example when a is greater than 1. So, do you agree here in this example the a value is greater than 1? It's 2. Okay, we're still going to do it the same way as the other problem. We're going to first set it equal to 0. So I just subtracted the 8 over. And we have to take out that GCF because in the second step it tells us that our a value must be 1. So we're only going to take out the GCF between the first two terms. That's the difference. So we're going to take out a 2, and we'll be left with x squared plus 8x. And then we're going to bring down the minus 8 equals 0. So now I want to take this inside and make it a perfect square trinomial. So I want to take half of the b value, so 8 divided by 2 squared, which is again 4 divided by 4 squared, which is 16. So we take that 2 on the outside, x squared plus 8x plus 16. Now we still have that minus 8, but the problem is I had to add and then subtract. But I can't just add 16 and then subtract 16, because you see this 2 out here? I'm technically multiplying the 2 by 16 again, so this would be 32 really. So in this case, we actually have to subtract 32 so that I'm going to account for this 2 in front here. And then we just solve it the same way. Now I have a perfect square trinomial, which I can factor, which again is this 4. 4 squared, it's half of the 8. So this will be 2x plus 4 squared. Then if I want to, I can really add these two, which is negative 40 equals 0. And basic algebra, I want to isolate this, right? I want to get x by itself, so I'll have to add the 40 first. I'll get 2x plus 4 squared equals 40. To get rid of that 2, I need to divide it. So I'll get x plus 4 squared equals 20. Now to get rid of this squared, I need to square root both sides. Remembering when I take the square root, it becomes a plus or minus radical 20. So I have x plus 4 equals plus or minus radical 20. Then I'll subtract 4 on both sides. So I'll get x equals -4 plus or minus radical 20, remembering to put the single number first. And I could break up radical 20 if I wanted to into 4 and 5, which becomes 2 radical 5. So my final answer is x equals -4 plus or minus 2 radical 5. Okay, now if we had to describe the roots are actually real. They're not imaginary because I don't see any eyes. Okay, I'd like to try the next page now. Okay, I'd like to do an example now that has an odd b value. So the first thing we always want to do is, again, set it equal to 0 like normal. So x squared, I'll subtract the 3x, add 10, equals 0. Okay, now I want to make this a perfect square trinomial. So I'm going to take half of b and square it. So b is -3. I'm going to have it and square it. Now, -3 divided by 2, you actually can't do that. So we're just going to square this expression. So why don't you put this into the calculator, pause the video, grab the calculator if you don't have it, and put it in just the way you see it with parentheses and everything. So this becomes 9/4. So when we're making my perfect square trinomial, we have x squared minus 3x plus some number minus some number, then add 10. The number we are going to add is simply 9/4. Now, what did we do before? We took this trinomial and we factored it using the have part. So since that part's not there, we're just going to use this. So this -3/2 is actually what the factors would be. So x minus 3/2. And then in the calculator, you'll just put in the -9/4 plus 10. So why don't you pause the video and see if you can do that. Okay, you should have gotten positive 31/4 equals 0. And remember this part, x minus 3/2, and then x minus 3/2 is the same thing as saying x minus 3/2 squared. And I could even subtract the 31/4 in the same sentence. Okay, and now what we're going to do, just like before, square root both sides, remembering that the square and the square root cancel each other out, and we need a plus or a minus. So we'll have x minus 3/2 equals plus or minus I rad 31/2. Now how did I get that? So this negative radical 31/4 can be broken up into radical -31 over radical 4. That's just the rule, that you could take the square root of the top, the square root of the bottom. And then I have a negative, so I just pulled out the I. So I have I rad 31, and the square root of 4 became 2. And then simply add 3/2 on both sides. And my final answer is x equals 3/2 plus or minus I rad 31/2. Remembering to put your single guy first. So final answer, my roots are imaginary. Alright, why don't you see if you can do the next example all by yourselves. Hit resume when you're done and the answer will be there. And any questions you have, you can ask me in class tomorrow.